Dear students, let us solve some more problems on limits and continuity. Let's have a look at the next question. Question number 24. Limit extends to 0, sine x grade divided by x. Sine x grade by x. See, you know that limit extends to 0, sine x by x is equal to 1. Okay. From last 1 week or 10 days or so, I am saying using this formula on each and every day. Limit extends to 0, sin x by x is equal to 1. This result is true only when x is in radians. If x is in radians, then we can say that limit extends to 0, sin x by x is equal to 1. If x is not in radians, say if x is in degrees, in case of limit extends to 0, sin x degree by x. How do you solve this problem? You convert this x degree into radians. How can we convert? As we know, 1 degree or 180 degree is equal to pi radian. Therefore, 1 degree is equal to pi by 180 radians. Hence, x degree is equal to pi x by 180 radians. Limit extends to 0, sin pi x by 180 divided by x we have. So when you have sin theta in the numerator, we want another theta in the denominator. So now there is sin pi x by 180. So I will write pi x by 180 here into pi by 180. As x tends to 0, this factor becomes 1. So the answer would be pi by 180. That is, if x is in degrees. But now the question here is, in this problem, x is in grades. What is grade? So first I will explain that unit, then we will solve this problem. See, how do we define a degree? One right angle, consider a circle, here there is a right angle, right? One right angle is divided into 90 equal parts. Each part is called a degree. Okay, so from there we say 90 degree is equal to one right angle. That means pi by 2 radians, which is equal to, that implies pi is equal to, pi radian is equal to 180 degree. But now in grade system, what we do is, one right angle is divided into 100 equal parts. In case of degree measure, we divide it into 90 equal parts. Here, in case of grade measure, one right angle is divided into 100 equal parts. Each part is called a grade. So 90 degree is equal to 100 grades, that is equal to pi by 2 radians. So from this I can write pi radian is equal to 200 grades. Okay, or 1 grade is equal to, bring this 200 here, pi by 200 radian. 1 grade is equal to pi by 200 radian. Remember this conversion. 1 grade equal to pi by 200 radian. Therefore, x grade, multiply this by x. X grade is equal to pi x by 200 radian. Remember this formula or this formula. Okay, this anyway you know, you are well versed with this formula. 1 grade equal to pi by 200 radians. That you should remember. Now coming to this problem. We have limit x tends to 0, sin x grade divided by x. Now I will write x grade in terms of radians, pi x by 200. So sin of pi x by 200 radian divided by x. We have x here, we want pi x by 200. Here in the numerator, sin pi x by 200 is there. So in the denominator also, I prefer pi x by 200. For that, I have to multiply and divide by pi by 200. Okay. As x tends to 0, sin theta, as x tends to 0, pi x by 200 also tends to 0. So now I can use sin theta by theta formula. So the answer would be, here this will give us 1. As x tends to 0, sin x by x is 1. This is 1 into pi by 200. Hence the answer is pi by 200. which is the fourth option. Okay. Let's have a look at this question now. 25th question. Limit extends to 1 secant pi x by 2 into log x. Limit extends to 1 secant pi x by 2. Secant pi x by 2 into log x is. Now, if I directly apply the limit as extends to 1, I am getting secant pi by 2 into log 1. What is the value of secant pi by 2? Secant pi by 2 is not defined. Or we can say secant pi by 2 tends to infinity because cos pi by 2 is 0. Secant pi by 2 is the reciprocal of cos pi by 2. This is not defined. So if I directly apply the limit, I am getting infinity into 0. Infinity into 0 is an indeterminate form. Okay. So what I do here is, I will take the secant pi x by 2 to the denominator. So we will have log x. When secant pi x by 2 goes to the denominator, it will become cos pi x by 2. Okay. So we have limit extends to 1 log x divided by cos pi x by 2. Okay. Now if I apply the limit as extends to 1, we get log 1 here in the numerator. Log 1 is 0. In the denominator, cos pi by 2. What's the value of cos pi by 2? 0. So this is of the form zeros by 0. Whenever we come across a problem where we end up getting 0 by 0, the immediate thing that comes to your mind or that should come to your mind is L-Hospital's rule, right? So use L-Hospital's rule here. Limit extends to 1. Derivative of log x is 1 by x. Derivative of cos pi x by 2 is minus sin pi x by 2 into the derivative of pi x by 2, which is pi by 2. Now apply the limit as extends to 1. As extends to 1, numerator to 1. Denominator minus sin pi by 2. Sin pi by 2 is 1. Minus 1 is there because of this minus. Into pi by 2. So this will go up. We get minus 2 by pi. Minus 2 by pi, which is the first option. Then 28th question. The value of limit extends to infinity. X into tan inverse of x plus 1 by x plus 2 minus cot inverse of x plus 2 by x. Okay. So now limit extends to infinity. X into tan inverse of x plus 1 by x plus 2 minus that cot inverse is there now, I will write it as tan inverse because cot inverse x can be written as tan inverse of 1 by x. By using that formula, I am writing this as tan inverse of x by x plus 2. Tan inverse of x plus 1 by x plus 2 minus tan inverse of x by x plus 2. Okay. So now if I directly apply the limit, this will be infinity. As extends to x will become infinity. Here x plus, you just concentrate on this factor x plus 1 by x plus 2. X plus 1 by x plus 2 as extends to infinity. Observe that both are polynomials of the same degree. So the answer will be coefficient of highest power of x divided by the coefficient of highest power of x, which means 1 by 1. This will give you 1. So this will become tan inverse 1. Tan inverse 1 is pi by 4. And what happens here? Let us concentrate on this factor x by x plus 2. As extends to infinity, x by x plus 2, they both are polynomials of the same degree. Both are polynomials of the same degree, hence the value of that limit will be equal to the coefficient of highest power of x in the numerator divided by the coefficient of highest power of x in the denominator, which is 1 by 1, that is 1. So this will give you tan inverse 1. Tan inverse 1 is pi by 4, here also pi by 4. Pi by 4 minus pi by 4 0. Here infinity is there. Infinity into 0 is an indeterminate form. Okay. And I cannot use L-Hospital's rule either. Okay. So what else can we do? I can use tan inverse x minus tan inverse y formula. That's equal to limit extends to infinity x into tan inverse x minus tan inverse y formula I would like to use. That is tan inverse of x minus y, which means x plus 1 by x plus 2 minus x divided by x plus 2 divided by 1 plus xy. Xy means x plus 1 by x plus 2 into x divided by x plus 2. That's equal to limit extends to infinity x into tan inverse of Here I will take x plus 2 as common fact, x plus 2 as LCM, and in the numerator we will have x plus 1 minus x. X plus 1 minus x is 1 divided by, here x plus 2 whole square is the LCM, so that x plus 2 gets cancelled. We will have x plus 2 whole square plus x into x plus 1 divided by x plus 2. X plus 2 whole square we had, one of those x plus 2 they have cancelled. Okay, then I'll continue here. This is equal to limit x tends to infinity, x into, I'll take the numerator, x into x plus 2. Okay, I'll take it instead. Sorry, limit x tends to infinity, x into tan inverse of this x plus 2 will go up, x plus 2 divided by, here I will simplify this. X plus 2 whole square will give you x square plus 4x plus 4 plus x square plus x. So x square plus x square, that will be 2x square plus, here you will get 4x and another x here. So 2x square plus 5x plus 4. Okay. Now this I divide by x plus 2 by 2x square plus 5x plus 4. I divide by this factor. Then to compensate it, I multiply by that. X plus 2 by 2x square plus 5x plus 4. Okay. Now as x tends to infinity, this expression will tend to 1. How? I will use the formula. Where do I use? Not enough space available here. Okay, I think I can write here. I will use this formula. Limit x tends to 0, tan inverse x divided by x is equal to 1. Okay, this formula I am using here. Limit x tends to 0, tan inverse x by x is equal to 1. Tan inverse x by x is equal to 1. Now one doubt may come to your mind. That is, so here x is tending to infinity, but in our formula we have x tending to 0, then how can I use that formula? Yeah, that's a valid question. See here, as x tends to infinity, what happens to this expression? You just concentrate on this. X plus 2 divided by 2x square plus 5x plus 4. As x tends to infinity, what happens to this expression? This expression, x plus 2 by 2x square plus 5x plus 4, both are polynomials. Here x plus 2 is there, here 2x square plus 5x plus 4 is there. Both are polynomial and degree of the numerator is less than the degree of the denominator. Denominator has a larger power of x. In that case, what will be the value of this limit? The value of this limit will tend to 0. As you know, if you have p of x by q of x, both are polynomials of different degrees. That is, if the degree of the denominator is larger, then as x tends to infinity, that tends to 0. So this expression, when x approaches infinity, this x plus 2 by 2x square plus 5x plus 4 will tend to 0. Therefore, I can use this formula. Hence, the value of this expression is 1. So that's equal to limit x tends to infinity, x into that much is remaining. So x square plus 2x divided by 2x square plus 5x plus 4. That's equal to. Now you observe that both are polynomials of the same degree. Now the answer is coefficient of highest power of x divided by the coefficient of highest power of x, which is 1 by 2. Okay, that's the answer. 1 by 2, third option. Next question, 29. If f of x is equal to sine of 1 plus step x by step x when step x not equal to 0, where and it is 0 whenever step x is equal to 0, where step x denotes the greatest integer not exceeding x, then limit x tends to 0 minus f of x is equal to. Okay, we are asked to find out the value of this. Next, x left hand limit as x approaches 0. Limit x tends to 0 minus x is approaching 0 from left side. Okay, say here step x not equal to 0 and 0 when step x is equal to 0. So step x is equal to 0 means what? I can rewrite it in this way. F of x is equal to sine of 1 plus step x divided by step x and 0 for step x equal to 0. Step x is equal to 0 means where does x lie? X should lie in this interval 0 to 1. Right? Closed at 0, open at 1. Because step x value at x equal to 0 it is 0, but at x equal to 1 it will be equal to 1. Okay. So between 0 to 1 this is what happens. And this is if x does not belong to this interval, okay, apart from this, wherever it lies, that is what happens. So now we are asked to find the left hand limit. When x approaches 0 from left side, that means it is not there in this interval. If you are finding the right hand limit, then this is what you have to consider. Now we are finding left hand limit, therefore this is what we have to consider. See, this is our real line. This is 0, 1, 2, 3, etc. Minus 1, minus 2, minus 3, etc. From 0 to 1, in this interval, the function is defined as, zero. But everywhere else, here as well as here, the function is defined as sine 1 plus step x divided by step x. Here also sine 1 plus step x by step x. Now x is approaching 0 from left side. If you are finding right hand limit, then you have to consider 0. Now you are finding the left hand limit, there it is defined as sine of 1 plus step x by step x. Okay? So I will write this as limit x tends to 0 minus x is approaching 0 from left side sine of 1 plus step x divided by step x. Okay, when x approaches 0 from left side means x is very close to 0 but less than 0. Say x may take the value minus 0.1, minus 0.01, etc. At those point what happens here? The value of this will be step of minus 1. Step of minus 0.1 will be equal to minus 1. So numerator will be sine of 1 minus 1 divided by minus 1. Sine 0 it is 0 by minus 1, that's equal to 0. So the answer is 0, which is the second option. Next, 32. Limit x tends to infinity, x plus a by x plus b whole to the power x plus b is equal to. Okay. See, I would like to recall one formula which you already know. I have explained it in our earlier class. That is, when you have limit x tends to a f of x to the power g of x. Suppose if you have limit x tends to a f of x to the power g of x, and if we directly apply the limit, if you are getting 1 power infinity form, then we can write this as e power limit x tends to a g of x into f of x minus 1. You know this formula? Do you? Yes. Okay. Now coming to this problem, if I directly apply the limit as x tends to infinity, x plus a by x plus b. If I directly apply, I will get 0 by 0. Sorry, infinity by infinity. But you know, both are polynomials of the same degree. When both are polynomials of the same degree, then the value of that limit will be coefficient of highest power of x divided by coefficient of highest power of x. So you get 1 by 1, which is 1, and the power will tend to infinity. So this is of the form 1 power infinity. Therefore, I can use this formula. So if I use this formula, there we are going to get e to the power limit x tends to infinity g of x. What is g of x here? X plus b into f of x minus 1. F of x is x plus a by x plus b minus 1. That's equal to e to the power limit x tends to infinity x plus b into, take LCM here, x plus b is the LCM, numerator will be x plus a minus x minus 2. X gets cancelled, here x plus b gets cancelled, so that will give you e to the power limit x tends to infinity, x plus b gets cancelled, what will remain here? A minus b, as x tends to infinity, a minus b will remain as a minus b only because it's a constant. So the answer is e to the power a minus b, e power a minus b which is the third option. Okay. 34th question. If A, B, C, D are positive real numbers, then limit n tends to infinity 1 plus 1 by A plus Bn to the power C plus Dn is equal to. So as n tends to infinity, here 1 by A plus Bn is a polynomial of degree 0, is a polynomial of degree 1, denominator has a larger degree, therefore this expression will become 0 as n tends to infinity. So 1 plus 0 is 1 and the power will tend to infinity. This is also of the form 1 power infinity. So I will use that shortcut again. So I can directly write this as e to the power limit n tends to infinity g of x. G of x is c plus dn into f of x minus 1. F of x is 1 plus 1 by a plus bn minus 1. 1 gets cancelled. So we will have 1 by a plus bn. That's equal to e to the power limit n tends to infinity c plus dn divided by a plus bn. This is equal to, here n is tending to infinity. These two both are polynomials of the same degree. This is here n is the variable. So the degree of n here, the degree of this polynomial is 1. Okay? C and D, A, B, C, D are constants. They are positive real numbers there, which are constants. N is the variable. So numerator is a polynomial of degree 1. Denominator is also a polynomial of degree 1. Hence, the answer is the coefficient of highest power of n in this case, because n is the variable, divided by the coefficient of highest power of n, which is here it is d, here it is b. So the answer is e to the power d by b. E to the power d by b, which is the first option. 35th question. Limit x tends to 0, 10 power x minus 2 power x minus 5 power x plus 1 divided by x into tan x. Okay. If I directly apply the limit, I am going to get 10 power 0, that is 1, minus 2 power 0 is 1, 1 minus 1 gets cancelled, minus 5 power 0, that is 1, plus 1. There also everything gets cancelled, denominator also 0 into 0. 0 by 0, we can use a L'Hopital's rule, but the x into tan x, again here we have to use product rule. So let us think of something else. I'll write 10 power x as 2 power x into 5 power x, right? 10 power x, 10 can be raised 2 into 5, so 10 power x can be raised 2 power x into 5 power x. Minus 2 power x minus 5 power x plus 1 divided by x into tan x. Okay? Then limit x tends to 0. Here I'll take 2 power x as a common factor. So then we'll have 2 power x into 5 power x minus 1. Between these two, I'll take minus 1 as common. So then you'll have 5 power x minus 1. Divided by, here what I do is, I'll divide by x into xn. Okay, multiplying and dividing by x. As x approaches 0, this tan x by x becomes 1. So in the next step, I'll just write x square. This x into that x becomes x square. Did you understand? Because x into tan x, instead of that, if you have only x square, that is easy to simplify. With that intention, I have divided my x. Then to compensate, I have already divided this. Okay. So then this numerator we can write as 2 power x minus 1 into 5 power x minus 1. Right? 2 power x, I'll take 5 power x minus 1 as common. Then here you'll have 2 power x and minus 1. Divided by this x square is there. I'll write x here and another x into x square. Okay. Now look at this. As x approaches 0, what happens to 2 power x minus 1 by x? And what happens to 5 power x minus 1 by x? Here we shall use this formula. Limit x tends to 0, a power x minus 1 by x, that's equal to log a to the base e. Here if you don't write the base also it's okay. So limit x tends to 0, a power x minus 1 by x is equal to log a. We know that formula. So here I am using that formula. This will become log 2 and this will become log 5. So the answer is log 2 into log 5, which is the third option. Then 36. Limit x tends to 0, 4 power x minus 9 power x divided by x into 4 power x plus 9 power x. I can directly write the given problem in this way. Limit x tends to 0, 4 power x minus 9 power x divided by x into limit x tends to 0, 1 by 4 power x plus 9 power x. Okay. So when you have limit x tends to a, f of x into g of x, we can write that as limit x tends to a f of x into limit x tends to a g of x, right? So you can take the limit, when you want to apply the limit for a product of two functions, you can apply the limit separately and later on you can multiply. Okay, so that I am doing. Why the intention behind it is directly we can write 4 power 0 is 1, 9 power 0 is 1, 1 plus 1 2, so 1 by 2 you can directly write. And here we have a problem. Because 4 power 0 is 1, 9 power 0 is 1, 1 minus 1 0, numerator 0, denominator 0. Okay, so when I say numerator 0, denominator 0, actually now I am treating these two as two separate problems. I will evaluate this limit and I will evaluate this limit and finally I will multiply those two. That should give us the desired answer. Okay, otherwise if I directly use it, go for L-Hospital's rule, differentiating this will take more time, taking product rule and all. Okay, so this is what I do. Now look at this, 0 by 0, here I use L-Hospital's rule. 4 power x into log 4 minus 9 power x into log 9 divided by derivative x is 1 into, here what happens, if I directly apply the limit also we will get the answer. 4 power 0 plus 9 power 0, 1 plus 1 2, so the answer is 1 by 2. Well, this limit is 1, not the answer. Okay, here if I apply the limit 4 power 0 is 1, so you are going to get 1 into log 4 is log 4 minus 9 power 0 is 1, so log 9 into 1 by 2. So I can write this as log 4 by 9 into 1 by 2, right? 1 by 2 into log 4 by 9 is the answer. Unfortunately, it is not present. Okay. So what do? I will give 1 by 2 here. And 4 by 9, 4 I will write as 2 square and 9 can write as 3 square. Together I can write as 2 by 3 whole square. So 1 by 2 into log 2 by 3 whole square. This looks like log m power n. Log m power n can be written as n into log m. So this will become 2 into log 2 by 3. 2 2 gets cancelled. So the answer is log 2 by 3. Do we have this option at least? Yes, we have. Second option, log 2 by 3 is the answer. Okay, next. 38th question. Limit n tends to infinity 1 by 1 into 3 plus 1 by 3 into 5 etc. till 1 by 2n minus 1 into 2n plus 1. Okay, so I'll just consider that nth term. You just observe the nth term. 1 by 2n minus 1 into 2n plus 1. Okay, I will write this as 1 by 2 into 1 by 2n plus 1, sorry, 1 by 2n minus 1 minus 1 by 2n plus 1. Can I write it in this way? How? Let us cross check. I'll take LCM here. LCM is 2n minus 1 into 2n plus 1. 2n minus 1 into 2n plus 1. Then numerator will be 2n plus 1 minus of 2n minus 1. That will give you minus 2n plus 1. 2n gets cancelled. 1 plus 1 is 2. 2 2 gets cancelled. So it will give you 1 by 2n minus 1 into 1 by 2n plus 1 on simplification. Okay. So I am writing 1 by 2n minus 1 into 2n plus 1 as 1 by 2 into 1 by 2n minus 1 minus 1 by 2n plus 1. Okay. Now this I think this creates one doubt in your mind. Sir, when you explain that this on simplification will give us this, it's okay, we understand. Hopefully. Then, but how do we get to know that this can be written as 1 by 2 into 1 by 2n minus 1 minus 1 by 2n plus 1? How should we get to know this? Okay. So, for me, if I look at it, I can directly write. But for you, it may not be that easy. So, I will give you one method how you can do it. Okay. That is called resolving into partial fractions. So, I will briefly explain how to solve this problem only as far as this problem is concerned. Later on, when we go to integration, there we will study partial fractions in detail. Okay. So now, here we have 1 by 2n minus 1 into 2n plus what you do is you write this as a by, here we have two linear factors, a by one linear factor 2n minus 1 plus b by another linear factor 2n plus 1. Okay. Now whatever we have in the denominator, you multiply by that. I am multiplying this equation by 2n minus 1 into 2n plus 1. Multiplying by 2n minus 1 into 2n plus 1. So here everything gets cancelled, you will have 1. And here what happens? 2n minus 1 gets cancelled, 2n plus 1 will remain. Here 2n plus 1 gets cancelled, 2n minus 1 will remain. Now we need to find the value of a and b. For that, put some suitable values for n. First, let us say I want the value of a. To get the value of a, you have to make this as 0. Put a value for n such that this becomes 0. How can I make this as 0? By putting what value for n can I make it as 0? By putting n equal to 1 by 2. So put n is equal to 1 by 2. When I put n is equal to 1 by 2, we get 1 is equal to a into 2 into 1 by 2, that is 1 plus 1 plus b into 0. So 1 is equal to 2a, hence a is equal to 1 by 2. Okay, so we got the value of a. Now I want the value of b. To get the value of b, I have to make this as 0. How can I make this as 0? This can be made 0 by putting n is equal to minus 1 by 2. So put n is equal to minus 1 by 2 here. So when I put n is equal to minus 1 by 2 here, 1 is equal to a into 0 plus b into, here when I substitute minus 1 by 2, 2 gets cancelled. Minus 1 minus 2 will give you minus 2. So 1 is equal to minus 2b, which means b is equal to minus 1 by 2. So a is equal to 1 by 2, b is equal to minus 1 by 2, that you substitute here, we get this 1 by 2n minus 1, I'll write here. 1 by 2n minus 1 into 2n plus 1 is equal to 1 by 2 by 2n minus 1 plus minus 1 by 2 by 2n plus 1. And take 1 by 2 as common, this is what you get. Okay? Now, if you have not understood, don't worry much about it. Now you just remember how to, you remember this formula later on during partial fractions. When you study integration, we will explain partial fractions. At that time, you will understand better. Okay. So now coming back to this problem. That nth term can be written like this. Now by putting different values for n, if I put n is equal to 1, I am going to get 1 by 1 minus, this is our Tn, right? Tn. So putting n is equal to 1, we will get first term, putting n equal to 2, we will get second term, etc. Okay. So that expression can be written as it's like this. Limit n tends to infinity, t1 plus t2 plus t3, etc. tn. This is what we have. T1, put n is equal to 1. If I put n is equal to 1, I am getting 1 here, 3 here. 1 by 1 into 3. Put n equal to 2 means 4 minus 1, 3, 4 plus 1, 5. 1 by 3 into 5 in that. Okay? Put n is equal to n, you will get tn. Right. Now, that t1, put n is equal to 1 here, we get 1 by 2 into 1 by 1 minus 1 by 3. T2 will be 1 by 2 into, then 1 by 2 I will take common, 1 by 2 into 1 by 3 minus 1 by 5. Then put t is equal to 3, that will give you 1 by 5 minus 1 by 7, etc. Last term is 1 by 2n minus 1 minus 1 by 2n plus 1. Okay? Now you observe here minus 1 by 3 is there, plus 1 by 3 is there. Minus 1 by 5 plus 1 by 5, etc. Everything gets cancelled apart from the first term and the last term. So you are left with limit n tends to infinity 1 by 2 into 1 minus 1 by 2n plus 1. That's equal to limit n tends to infinity 1 by 2 into, take LCM, 2n plus 1. This numerator will become 2n plus 1 minus 1. Okay? Now 1 gets cancelled. Here 2 gets cancelled. So this leaves us with limit n tends to infinity, n by 2n plus 1. N by 2n plus 1. Now observe that both are polynomials of the same degree and n tends to infinity. Now the answer is the coefficient of highest power of n divided by the coefficient of highest power of n. So answer will be 1 by 2. 1 by 2 means second option. Okay, with this I will stop today's class. We'll continue tomorrow. Thank you.